All right, good morning. Welcome back to Elements of Calc 2. So today we're going to be talking about something called the definite interval. It's definite interval. And the only thing that really is going to change here is that we are going to add limits to our integration. So instead of just having a definite, which didn't have any numbers up and down here, we're going to change that to a definite interval, which is going to have little limits. Okay, integration. That's what these are called. Okay, and we're going to just go with x to the 3 plus x squared dx. The same rules of the integration you've already learned still apply. So we're just going to end up with 1/4 x to the 4th plus 1/3 x cubed. And we're going to draw a line here that goes from 1 to 3. Okay? So from here, what we're going to do is we have to go ahead and evaluate what's going to happen. So we're going to say we have 1/4. Actually, let me go ahead and do it this way. Let's go ahead and do this. We've got 3 to the 4th over 4 plus 3 cubed over 3. This is x evaluated at 3. And we're going to say minus, and then we have 1. Okay, so we have 1 to the 4th over 4 plus 1 to the 3rd over 3. Okay, and then we have some arithmetic to do. I'm going to go ahead and leave myself a little note, x evaluated at. Okay. So we've got some arithmetic to do. And I would urge you to do a little bit of arithmetic before you type everything in the calculator. It's way too easy to kind of let the calculator have a jumble of numbers in there, kind of get lost in the weeds for it. So I would say lay your arithmetic out so you can follow it and track what's going on. And then when you're done with what you want to lay out, go ahead and type into the calculator and get an answer for that. So we have 81 over 4 plus, and this is going to be 27 over 3, okay, minus, we have a 1 over 4 plus a 1 over 3, right? Just 1 cubed is 1, 1 to the 4th is 1, so we're sitting here with this. So I've got 81 fourths plus 27 over 3, that's 9, okay, minus 1/4, and this negative sign distributes both of these, minus 1/3, and now we're ready to use the calculator. Now, the calculator I have is a little bit more advanced than the one they're allowed to use, okay, but a basic scientific calculator will pretty much suffice for everything that you need. So we have 81 divided by 4, okay, plus 9, minus 1/4, 4, minus 1 divided by 3. And say enter, and we ended up with 28 and 0.67. Let me show you a little trick on the other calculators. There's an ABC button. That moves from fraction to decimal. So I'm going to go ahead and say F. We're going to just change it to a fraction, just easier to work with. And we ended up with 6 over 3. Okay, so that's what we have for that. Okay, so we have good. So that's what we end up with. Okay. Yeah, so we're all set. Okay, so that's what your answer would be for this thing. And this tells you the area under the curve between these 2 points, because this function isn't, it doesn't have like a weird thing to it. It goes from 1 to 3. We don't go to negatives. We're just okay. Okay, let's talk about some properties of integrals here. Okay, so one property of a definite integral to talk about is, what if I have an a less than or equal to a b less than or equal to a c? Okay, so that means if I have integral f of x from a to c, we can stop off at this middle point. We could say this is going to go from a to b, f of x dx, plus b to c, f of x. Go ahead and integrate this one, integrate that one, plug these limits in, and go ahead and get ourselves an answer that way. So later on, when we talk about improper integrals, this will be more important, but we will do an example today of where you would need to break up these limits in order to make sure we're getting the correct answer. Okay. Another property is if I have the negative f of x dx from a to b, okay, we can separate this out and say that this is an integral from b to a of f of x dx. So if you have one of these negative signs here, you don't want to deal with it, you can go ahead and integrate and then swap the signs, and that will take care of this negative sign out front. Okay, so occasionally we'll do that, and it's helpful later on when these problems get a little tedious and it gets hard to track everything. So that's why you might want to do that. You never have to, but I tend to do this a lot in order to not use negative signs, just to let you know that this is what's happening to me. And you're allowed to use it too. So let's go ahead and look at my next problem. So what I'm going to do is we're going to say, this is what we're going to have to need to divvy up these limits here. So this one's a little bit complicated, and let's go ahead and talk about trying to get this integral. So I'm going to go from, what do I want? I want -3 to +3, I think. Yeah. There we go. Yeah. And we are going to be dealing with the problem that I want is going to be x cubed, okay, plus x squared minus 6x. Okay, double check to make sure that's what we're getting. Yeah, that's what we have, dx. Okay. So and actually I'm not quite done here. So I can find the area between the x-axis and f of x. They might say find the total area under the curve, something like that. Find area between the x-axis and f of x. Okay, so when you have this problem, they don't ask you an integral. So a lot of problems that just say integrate it. Okay, I don't have to worry about anything. You're finding an area, then we have to be a little bit careful. I'll show you why. So if we go back to our college algebra days and say, what if I wanted to graph this function? Could we graph this x cubed plus x squared minus 6x? Well, it's a third degree polynomial, okay, with a leading coefficient of a 1. So I know my basic shapes are going to look like that, my end behavior. And what we have to do is find our zeros. So this is my end behavior here. Okay, we have this back from nightmares of college algebra. Okay, so what we're going to do is we're going to find our zeros. So I've got x cubed plus x squared minus 6x. This is equal to x times x squared plus x minus 6. See how they just factored out an x there? And then what we're going to do, we're setting this equal to 0 because we want to find our zeros. So we're going to keep factoring. We're going to say x plus 3 and x minus 2. And that will go ahead and take care of all the pieces that we need here. So to find our zeros, we're going to say each of these equal to 0. So we're going to say x equals 0, or x plus 3 equals 0, x equals -3, and x minus 2 equals 0, i.e. x equals 2. Right, so let's go ahead and give ourselves a little plot of this thing. So what's going to happen is 1, 2, 3, 0, 2. So we're going to have a graph that kind of looks like this. It's going to come up here. It's going to come here. Now, where are we going? We're going between 1 and +3. Here's 2. Here's 3. So what we really want out of this integral is we want these three areas. So we want area 1, we have an area 2, we have an area 3. Now the problem with area 2 is it's going to look negative because it's completely under the axis. We're going to take its absolute value. It's going to change to a positive. It's going to add these three areas together because that's going to give us the total area between the x-axis and this function. Okay, so be careful about how they're asking it. So you might have to go through and do this. Just to let you know, this is about as complicated as they get. We don't go into like 17 different regions. We don't do that to you. Pretty much stays at this level. Okay, so a little bit of practice with these. You'll be in this range. You'll be really good, and you'll be able to go ahead to that. So what we're going to have here is we have to integrate between -3 and 0 of this function. Plus, and then we're going to go from 0 to 2 for this function. Right, the zeros match up. And then we're going to add in from 2 to 3 this function. Okay, so that's what we're trying to do with all of this. Now, you could do this in any way that helps you keep all of this stuff straight. You want to do the integral 3 times, that's fine. Just try to make sure that you write down the same thing all 3 times. If you want to say, you know what, I'd like to know what the indefinite integral of this function is first. So if I just go ahead and say, what is my indefinite integral, right, of my x cubed plus x squared minus 6x dx, just go ahead and do that, and then substitute these things into each of the 3 regions that I need. That's just fine. That's probably the way I'm going to do this, to say that this is equal to x to the 4th over 4, okay, plus x cubed over 3 minus 6x squared over 2, and then we've got to go from a lot of a's and b's here. Got 3 different regions to go with. Just going to write a to b for now. We're going to clean this up a little bit. We're just going to say this is x to the 4th 4 plus x cubed over 3. And then 6 over 2 is 3, so minus 3x squared. Okay, now I've got 3 different regions to go ahead and deal with. We're going to go from -3 to 0. So my first area, area 1, is equal to, we're going to type in when x equals 0 and x equals -3. So if I go ahead and type in my 0, this one's pretty easy to deal with, right? We end up with 0 minus, and then I've got to deal with the x equals -3. So I've got -3 raised to the 4th power over 4. Be careful with your signs, be careful with your parentheses. Plus -3 cubed over 3 minus 3 times -3 squared. Okay, so that's what we're dealing with our first area. So again, this is a little bit slow. Don't forget your minus signs on the outside here. That's really important. -3 to the 4th is going to turn positive, so we end up with 81 over 4. Okay, we have -3 times -3 times -3. This is going to be a negative. We're going to have 27 over 3. Okay, plus, actually rather, minus. Okay, because what I'm looking at is I'm carrying this negative. So we have minus -3 times -3 is going to be a positive. So we have 3 times 9, so we have a 27. Okay. So this is going to be 0 minus, I've got 81/4 minus 27 over 3, that's 9, and then minus 27. Okay, notice all of these are minus. There's a minus on the outside, so we're going to put all minus, but we'll go ahead and use the calculator to help us out with this. Okay, so we've got 81. Let's go ahead. We've got 81 4 minus 9 minus 27. We'll go ahead and say equals for that. And we ended up with -7, -15 3/4. Let's go ahead and change this to a fraction. Okay, so we ended up with the negative of a negative. Okay, so we're actually going to end up with a positive. The calculator thinks it's negative, but it doesn't account for this guy out here. So we end up with a 63 over 4. This is my area. Okay, so we have to go ahead and do it. What about area 2? Okay, they start getting more tedious as we go forward here. So area 2 is going from 0 to 2. Okay, we're going from 0 to 2 here. So we're going to go ahead and we're going to have the same definite interval here. So we have x to the 4th over 4 plus x cubed over 3 minus 3x squared, right? And we're going from what to what? From 0 to 2. So let's go ahead and plug these things in. So we have 2 to the 4th over 4 plus 2 cubed over 3 minus 3 times 2 squared. Okay, this was my x equals 2. Minus, when I plug in a 0, we get 0, 0, and 0. So minus 0. So that's not going to be too bad. Okay, 2 to the 4th is 16, so we end up with 16 over 4, plus 2 cubed is going to be 8 over 3, minus, and then we have 3 times 2 squared is 2 squared is 4, 4 times 3 is 12. Okay, so we ended up with this piece. So let's see here. We ended up with, let's go back to here. I've got 16 over 4, which is 4, okay, plus 8 over 3, and then minus 12. Okay, and again, I'm going to go ahead and change this to a fraction. So math, change to frac, so that we can go ahead and add it as one number. And I ended up with negative 16 over 3. Now remember when I went through and I graphed it all the way up here, and I said, hey, this is under the area, this is under the curve, the axis. So it doesn't surprise me this came out to be a negative number. So technically this is my area 2. But what did I say what we're going to do? We're going to say we need the absolute value of area 2 because we're trying to get the whole area between the x-axis and the function. So we're just going to say this is 16 thirds. Be done with that. Okay, so then we ended up with 16 thirds there. Okay, now for here, okay, the next little piece for this, we're going to be at 2, and we need to go from 2 to 3. Okay, because that was going to finish out our integral. So we're going to go from 2 to 3. This is going to be the hardest one. So again, same function that we're dealing with. We have x to the 4th over 4. Okay, and I'm trying to take this real slow so you can kind of see where all the pieces fit in. When you do this yourself, you will go faster than what I am showing you right now, and that's fine. Okay, just realize that we are going from 2 to 3 here. Okay, so that's the last thing we have to deal with. So let's go ahead and type this in. So we have 3 to the 4th over 4 plus 3 cubed 3 minus 3 times 3 squared. And this little bit here, this was x evaluated at 3 minus x evaluated at 2. We need 2 to the 4th over 4 plus 2 cubed over 3 minus 3 times 2 squared. This was x evaluated at 2. Okay? And then we'll go ahead, now that we have a ton of arithmetic to deal with, we'll go ahead and work through that. So 3 to the 4th, that's 81 over 4, plus 3 cubed is 27, 3, and then we have a minus here. 3 squared is 9, 9 times 3 is 27. Okay, and then we have this bit here, okay, minus, don't forget, we have to actually deal with this negative sign like this. 2 to the 4th, again, is 16, so we end up with 16 over 4, plus, and I have 8, 2 to the 3 is 8 over 3, okay, and then minus, 2 squared is 4, 3 times 4 is 12, okay, so again, we have x equals 2, x equals 3, so I kind of tell where I am with this. We'll do one more round of simplifications here to say this is 81 over 4, 27 over 3 is 9 minus 27. Then I've got minus 16 over 4 is 4. This negative is going to distribute, so we have minus 8/3. Again, this negative distributes, so we end up positive 12. I think I'm ready to put things into the calculator now. I don't. Calculator can do some of the work. Just urge you to say, don't let it do all of the work because it's easy to lose where we are with all the buttons. This was A3, so this is my third area. So it's really important to remember where we are in our problem. So I have 81 over 4 plus 9, okay, minus 27, minus 4, minus 8/3, okay, then we have a plus 12. Calculator sort all of that out. Hopefully it'll work out pretty well. So I'm going to go ahead and change this to fractions. I think it's a little bit easier to look at. That's for me. I like the fractions. You can leave them as decimals, that's fine. But I ended up with 91/12. Delightful. Sure. The last thing we have to do is we have to say this was A1 plus A2 plus A3, remember? So let's go ahead and round up. What was our A1, our A2, and our A3? So A1 was 63/4. Okay, so we have 63/4. And then we're going to add this. We said we need the absolute value of this piece here. So what was my A2? We are saying that this is 16/3. 16/3. Okay. And then finally we have plus 91/12. So we'll go ahead and type that into our calculators and not really worry too much about the arithmetic because the calculator will handle it. So we have 63 over 4, okay, plus 16 over 3, okay, plus, what was this? This was 91 over 12. Over 12. We'll say equals. Again, I'm going to change this to a fraction just because I think that's a little bit easier to look at. But you are more than welcome. I would say go to at least 3 decimal places, but you're more than welcome to use decimals. This is 86 over 3. Okay. A lot of times the answers in the back of the book, the answers that my math lab expects you to type in are fractions. So that's why I like to do fractions instead. But you guys will see in the homework, say there's definitely going to be problems where it's like round this to 3 decimals, round this to 4 decimals, whatever. Please round it to those number of decimals in order to type your answer into the okay, so that's kind of a long example, and I did make it longer because I kind of belabored typing out all of this arithmetic. You're going to get faster when you won't need to do all of this. I'm just trying to go real slow and show everybody where all the steps are with this. You will encourage to go faster than this, okay? So careful with the rules, like careful with the words when it says, find the area between the x-axis and the function, or find the total area enclosed by the curve, find the total area enclosed by 2 curves, something like that. So when you're talking about area, be real careful about what you're actually dealing with. You might have to graph it. I'm going to leave it with this example. We will do some more too with this. Thank you very much for watching the video.